Another day, another story. Why don't cars use carbon capture? Carbon capture refers to the process of extracting carbon dioxide, CO2, from exhaust gases and storing it underground to mitigate its impact on the environment. While this technology has been explored and implemented in power stations, its application in cars remains a challenge due to several reasons. Challenges of carbon capture in cars. A. Mobility and storage limitations. Cars, unlike power stations, are constantly on the move, making it difficult to implement carbon capture technology effectively. The captured carbon must be stored within the vehicle and then transferred to a processing facility for proper disposal or utilization. This mobility factor poses a significant challenge in developing a practical and efficient system. 1. Cars' constant movement. Unlike power stations that are stationary, cars are designed for transportation and have varying routes and destinations. 1. This movement makes it difficult to capture and store carbon emissions consistently and efficiently. 2. Need for onboard storage. For carbon capture to be implemented in cars, onboard storage systems capable of safely containing the captured carbon are necessary. 2. Developing such storage solutions that are compact, lightweight, and effective poses technical and engineering challenges. B. Technological limitations. Implementing carbon capture technology in cars involves complex systems and processes. Several technological limitations hinder its widespread adoption. 1. Complexity of carbon capture technology. Carbon capture systems require intricate mechanisms to capture, separate, and store CO2. 1. The compact nature of cars presents limitations in terms of available space and energy requirements, making it challenging to integrate and optimize carbon capture technology. 2. Cost-effectiveness and scalability concerns. The development, installation, and maintenance costs associated with implementing carbon capture in cars may currently outweigh the potential benefits. 2. Additionally, current developments in carbon capture technology. A. Elon Musk's $100 million prize. 1. Motivation behind the prize. In a significant effort to combat climate change, Elon Musk, the Tesla co-founder, has pledged a $100 million fund to encourage inventions that remove carbon dioxide from the atmosphere or oceans. 1. Musk's motivation stems from the urgent need to find innovative solutions to reduce carbon emissions and mitigate the impact of climate change. 2. Encouraging innovation in carbon capture technology. The $100 million prize fund, donated by Elon Musk, aims to incentivize scientists, researchers, and inventors to develop groundbreaking technologies that effectively capture and remove carbon from the air or water. 2. This competition fosters an environment of creativity and encourages the exploration of novel approaches in carbon capture, driving the advancement of technology in this crucial field. B. Perception versus reality. 1. Misconceptions about carbon removal. There is a tendency for some to perceive carbon removal as a simple, cheap, and easily scalable process. 1. However, it is essential to address the misconceptions surrounding this technology. 1. While carbon capture holds promise, it is a complex process that requires careful consideration of various factors, such as energy requirements, storage, and cost-effectiveness. 1. Understanding the challenges associated with carbon removal helps set realistic expectations and avoids overhyping its potential. 2. Importance of addressing scalability and reliability. Scaling up carbon capture technology is crucial for its widespread adoption and effectiveness. 2. It is essential to ensure that carbon capture solutions can be implemented on a large scale, accommodating the significant emissions generated by various industries, including the transportation sector. 2. Furthermore, reliability is a critical factor to consider, as consistent and dependable carbon capture technology will be necessary to achieve meaningful reductions in greenhouse gas emissions. 2. By acknowledging the need for scalability and reliability, the focus can be placed on developing robust and practical solutions. IV. Alternatives to carbon capture in cars. A. Transition to electric vehicles. 1. Growing popularity of electric cars. As an alternative to carbon capture technology in cars, the transition to electric vehicles, EVs, has gained significant momentum. 1. The automotive industry has witnessed a surge in the production and adoption of electric cars, driven by advancements in battery technology, improved charging infrastructure, and increased consumer demand. 1. Electric vehicles offer the potential for zero-emission transportation, reducing the need for carbon capture in the automotive sector. 2. Reduction of carbon emissions through electrification. By replacing internal combustion engines with electric powertrains, electric vehicles help reduce carbon emissions directly at the source. 2. The electricity used to charge EVs can be sourced from renewable energy, further enhancing their environmental benefits. 2. This shift toward electrification not only addresses the issue of carbon emissions but also promotes sustainable transportation solutions. Conclusion. In conclusion, while carbon capture technology holds potential for reducing emissions in various sectors, including cars, there are challenges to its implementation. The complexity and cost-effectiveness of retrofitting existing cars with carbon capture systems pose significant hurdles. Therefore, exploring alternative solutions becomes crucial. One promising avenue is the focus on sustainable fuels, which offer advancements in renewable and low-carbon options. Sustainable fuels, such as biofuels, hydrogen, and synthetic fuels, have the potential to reduce emissions without relying on carbon. By transitioning to sustainable fuels, vehicles can operate with lower emissions, contributing to decarbonization efforts. Can carbon capture technology be retrofitted into existing cars? Retrofitting carbon capture technology into existing cars poses challenges due to the complexity and cost associated with modifying the vehicle's systems. It requires significant modifications to capture, store, and process carbon emissions. As of now, retrofitting carbon capture technology into existing cars is not a widely implemented solution. 2. What are the potential environmental benefits of carbon capture in cars? Carbon capture in cars can potentially reduce greenhouse gas emissions, helping mitigate climate change. By capturing and storing carbon dioxide emissions, it can contribute to lowering the overall carbon footprint of the transportation sector. However, it is important to consider the entire life cycle analysis, including the energy sources used for carbon capture, to assess the net environmental benefits.